In case somebody wants to review this, they can. We'll just record this. Today's going to be a really quick and easy lesson, by the way. And also, just so you're aware, these are the IXL assignments that we did last week. So we're going to have time today to do an assignment. It's going to be a very short, easy assignment. If you're not done with all these, probably tomorrow or Thursday, I'll be entering homework 12. These will be on homework 12, and I'll probably be putting them in on Thursday because Friday of this week, we're going to take a test. And so Thursday, you guys will be reviewing and I'll have lots of time to get that done. So just keep in mind, Friday is going to be a test. All right, look at number 3. It says, Martiz, solve this equation. Explain Martiz's error. All right, here's what I want you to do. Pretend you're the teacher. What did Martiz do wrong? What did Martiz do to get from this step to this step? Write this down in your book. What's different about this step than that step? What did the Martiz do to get from there to there? Subtract x. Good. Write that down. We're going to subtract x. Did Martiz do a good job of subtracting x from both sides? You would, but you're going to see where Martiz is going with this in a minute. You would think so, yes, but I think I actually like the way Martiz is doing this. But does everybody agree that if you subtracted x from this side, it would just disappear? And if you subtracted this x from this side, it would just show up as a minus x. You might have put it as 2 minus x. He decided to put it as negative x plus 2, but it's really the same thing, isn't it? Same thing. All right, what did Martiz do to get from this step to this step? Martiz didn't like something, and Mr. Vickers always tells you that if there's something you don't like about an equation, change it so that it is something that you like about it.
It's negative.
Yes, he did something with a negative, didn't he? What do you do to get from there to there? How do you get from negative square root of x to positive square root of x? And what do you have to do to switch the signs? That's what I'm asking. You don't add, you do what? Multiply or divide. But didn't he just multiply both sides by a negative? If you multiply this by a negative, don't you get a positive? And if you multiply this by a negative, don't you just switch the signs? So write down that he multiplied by -1. And you're allowed to do that. I think he did that just because he didn't like this negative x plus 2. He wanted to have positive x. Everything works better when you're multiplying if there's a positive x there. So he just decided he wanted a positive x. I think that's a really good idea. Okay. Now, what did Martiz do next? What did he do to get from here to here? Squared both sides. Okay, let's do that. All right, he squared both sides. Obviously, the square root of x squared is x. I don't need to figure that out. But what is x minus 2 squared? Isn't that the same as x minus 2 times x minus 2? And what famous mathematician showed you how to multiply 2 binomials? Whose method did you learn to use? The what? File. That's right. There's a famous mathematician named File a long time ago who came up with the File method. F stands for first. So what's x times x? Write that down, x squared. Then the e and the I part of File you can do together in one step. What's negative 2x and negative 2x when you put them together? Negative 4x. And the L part of File is last. So what's negative 2 times negative 2? Positive 4. And so when Martiz, I hope I'm pronouncing his name correctly, when Martiz wrote x squared minus 4x plus 4, he actually just did, maybe he did the File method in his head, but he just went from here to here in one step. I just wrote it out here so you can see how that happened. Everybody still with me? Okay. By the way, we have to find Martiz's error because his answer is wrong. Have we found it yet? Have we done anything wrong? I don't think so. I'm going to find out. The next step, what did Martiz do to get from here to here? He said, yeah, this was an x. He subtracted x from this side. What's negative 4x minus 1x? Negative 5x, right? So write down here that Martiz subtracted. He subtracted x. Write that down. And I think that was a good step. He just subtracted it from this side and he subtracted it from this side. So far, we're good. Now, this step is everybody's favorite step because everybody always says this is the part that they don't know how to do. So we're going to talk about it. He factored. He thought to himself, what two numbers multiply to 4? And the first two numbers that he thought were the same two numbers that you thought. What are the two numbers you think of? 2 and 2, right? The trouble with 2 and 2 is there any way you can get a 5 when you add 2 and 2 together? No. So Martise went back to the drawing board and said, there must be a different way to multiply and get 4, and that's 4 and 1. Is there any way you can get a 5 from 4 and 1? A negative 5, they would both have to be what? Negative. How's Martise doing so far? So far, I like everything he's done, right? Right? Because negative 4 times negative 1 is positive 4. But when you do the file method part here, negative 4x and negative 1x would be negative 5x. Everything he did there is perfect. So tell me, what could Martise plug in for that x that would cause this factor to go to 0? 4. And that's what he wrote. And what could Martise plug in to this factor that would, for x, that would cause this factor to be 0? 1 minus 1 is 0. And so Martise wrote that the solution is 4 and 1.
So there is no mistake.
There is a mistake. Yes. What? He put or. Oh, that's actually not the mistake. That's a good try though, because we didn't talk this. Usually you think or on greater than or less than. That's a really good guess, but that's not it. By the way, when you're solving equations, what's an easy way on a test to find out if you got it right or wrong? Plug it in. Let's try the 4. What is the square root of 4? 2. What's 4 minus 2? 2. I like that. That's good. What is the square root of 1? What's 1 minus 1? What's 1 minus 1? It's clearly 2, isn't it? No, it is not. Therefore, what kind of solution is this? This is a good solution. I like that solution. What would we call that? It's on the previous page. Remember these problems that you did? Yeah, it's called an extraneous solution. This is, write this down, extraneous solution. This does not work in the original. X plus 1 is not a good solution because it doesn't work in the original problem. We created an answer that doesn't exist. Okay? So actually Martise did everything right. He just didn't check his answer. That's the only mistake he made. This answer is right, but this answer was wrong. So what I would like you to do now is to try number 4 on your own right now. Give you a few minutes. See if you can solve for x. See what you get. You don't have a pencil. Here. I've got a pencil. See if you can solve for x. Do a little algebra magic on that and see what you get. If you need to ask the person next to you for help, that's totally okay. See how you do it.
Can you square first?
You should square first. Yes, yes, I would do that. That's a really good idea. If you're not sure what to do, take McLean's advice and square both sides first. That's an excellent idea because I don't like that square root any more than the rest of you do. And one good way to get rid of a square root sign is to square both sides. So do that first on your very first step. That'll make everything way more fun. So I'm gonna even write that in here. That's a good first step. Square that side, square that side, and then keep going. when you get done, you should get more than one answer. And then don't make the mistake that Martise made. Go back and check your answers. And don't forget about that famous mathematician that taught you how to multiply two binomials together. This is an excellent way of multiplying two binomials together, because this really means this. Right? I'll give you a hint. That famous mathematician's last name was Feil, F-E-I-L. It's totally okay to ask the person next to you for help. What are they doing that you're not doing?
I erased it because of.
All right, do you need help with the hard part? What happens when you square a square root? What happened when Martise squared a square root? What did he get? What happened to the square root symbol when Martise just squared the square root? It just disappeared. What's going to happen on this side when we square root, when we square a square root? What's left over? X plus 1. There you go. How do we do getting to this point? Okay. Now, what famous mathematician taught you how to multiply two binomials together? Let's do that. What's x times x? Write that down. Don't watch me do it. My last name is Feil. I know how to do this. It kind of comes natural to me. What is E? I'm going to do the E and the I in my head because I think you guys can handle it. What's E? Negative 1x. What's I? Negative 1x. What's negative 1x and negative 1x? What happens if you buy something for $1 that you don't have and buy another something for $1 you don't have? Are you getting out of debt or are you going further into debt? So let me ask you this again. What's negative 1 and negative 1 when you put them together? Very good. Negative 2. Negative 1x and negative 1x is negative 2x. And then the L part of Feil is negative 1 times negative 1. When you multiply two things that are negative, then what happens? Then you get a positive. There we go. Hard part is done. Whew. Now we just got to solve. Let's do like Martise did. He tried to get everything equal to 0 up there. So what do I got to do to try to get everything equal to 0? Let's try to get the 0 over here. How do I get rid of an x? Subtract it. I'm going to subtract it from the thing that's a like term. What else is over there that I could get rid of? The 1. How do you get rid of a plus 1? subtract 1. I'm going to subtract it from the like terms. That way it makes it a lot better. Now, I didn't subtract anything from x squared, so I'm just going to write this down. Now, here comes the hard part. What is -2 minus 1? -3. Excellent. What's 1 minus 1? 0. It's gone. So I just go equals. And what happens when I subtracted all this stuff? What's over on this side? 0. All right, we are almost there. Because now, in order to solve this quadratic, we need to factor. Now, we're not even going to do it the hard way. Mertens had to do it the hard way. He had to figure out what multiplied to that and added to that. We don't have to do that. Ours is way easier because all we have to do is find the greatest common factor. Yeah, what's the greatest common factor that goes into x squared and 3x? X. So everybody do that. Take out the x. It's like doing the distributive property in reverse. So you're taking out the x instead of multiplying through by the x. X times what is x squared? X minus x times what is -3x? -3. And you're almost there. What could I put in for x right there that would cause that factor to be 0? 3. And what could I put in for x right there that would cause that factor to equal 0? 0. So you get 2 answers, 0 and 3. This is where Martese went wrong. We're not going to make the same mistake. We're going to take our answers and plug them back in. Let's take the 3 and plug it in. What's 3 minus 1? 2. I'm going to write that down so I don't have to think about it too hard. What is 3 plus 1? What's the square root of 4? What do we think about that answer? I like it. It's a good answer. It works when I plug it back in. So I think 3 is a good answer. How about 0? What's 0 minus 1? -1. What is 0 plus 1? What's the square root of 1? Did it work? It did not work, did it? It absolutely, hi. Sorry. Mr. Davenport is the next one up this way. Why did Traven look so nervous? Traven's was like, he's sweating bullets over there. Poor Traven. He's like, woo, made it. All right. So is -1 equal to +1? I'm going to say no, they're not equal to each other. And therefore, which answer is good? So x equals 3 is a good answer. 0 is not a good answer. That is what we call extraneous. I can't spell, so I'm just going to put EX. That's an extraneous solution, but x equals 3 is a really good answer. So moral of the story is just solve the equations the same way you solve them always, but check your answers when you get done. Because sometimes when you're solving, you create an answer that really isn't correct. All right, turn to the next page. Turn to the next page. All right. You're going to find the farther you go in science class that you're going to have lots and lots, not just science class, but there's lots of different applications for this. There's lots of real world applications for this. And so let's talk about these. Let's do a couple of these because on the ACT test that you're going to be practice taking next week, there are lots of problems just like this. And you need to learn how to cut through the stuff that's not important and go right to the stuff that is important. All right, here's my least favorite part of the ACT math portion. You know what it is? Reading. Half of the math portion of the ACT is the reading portion because they don't care that you know the math. They only care that you know how to read. Okay. How are you good at reading, Will? Will, you'll read way better if your eyes are open. So keep them up here. There you go. All right, here we go. The Buford scale is a system that measures wind speed and describes conditions at sea and on land, blah, 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 0 to 12, blah, 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 74 miles an hour, blah, blah, blah. I don't care. Why don't I care? Because on the ACT, it's going to give you a great big formula or great big paragraph like this. And they already tell you the formula right here, right? Well, you okay? You need to, you'll learn way better if your eyes are open. All right, so here's the formula. What are they asking us? They say 20 miles per hour. Is 20 miles per hour the Buford number or is that the velocity of the wind? 20 miles per hour. Does that sound like a Buford number or a velocity? Put it in for velocity. don't even read the paragraph. Just put in 20 equals 1.837 b to the 3/2 power. I'm not even going to read the paragraph and I'm going to get this one right, because you don't even have to read the paragraph. They give you a formula and they ask you to plug in a number. That's all it is. If you really are concerned about what the Buford scale represents, then figure out, all they want us to do is figure out B. They want to know the Buford number. I'm not going to do part A. We're just going to do part B, because this is more like what you're going to see on the ECT test. So here we go. I want to get B by itself. What's keeping B from being all by itself? How are you going to get rid of that 1.8 thing? Is it being added to the B or is it being multiplied? What's the opposite of multiplying? Dividing. So on your calculator, if you don't have a calculator, go get a calculator because you're going to need one. Take 20 and divide it by 1.837. So take that big ugly number and write it down. I'm not going to write the whole number down, but I'm also not going to get it off of my calculator. No, don't round anything off until you get all the way to the end. Because is IXL really picky about whether you're off by a tenth? Yes, it is. And so you don't want to be off by a tenth. You don't want to round anything off till the very end. Is B all by itself? What's keeping it from being all by itself? The 3/2 power. So I want to get rid of the 3/2 power. So I'm just going to write 10.88, but I'm going to leave it on my calculator right here. What power would I have to raise this to make it just plain old B? Remember, when you take the power of a power, you multiply. What would I multiply 3/2 by to get 1? Not 0, not 1. What do you multiply a fraction by? Like 3/2 times something equals 1. No, what would I want to have on the top so it cancels out with this 2? 2. What would I want to have on the bottom so it would cancel out with this 3? 3. So what should I take this to? The power of 2/3. Because that way, 3/2 times 2/3 is 1. And I've got B all by itself, which is what I want. But I also have to do that to this side. What power do I have to take this side to? 2/3. Now, do you still have that number on your calculator? Oops. There it is, 10.888, whatever, blah, blah, blah. All I have to do now is raise that to the what power? 2/3. Make sure that the 2/3 is in the numerator or in the exponent, just like that. Notice that I hit answer. That way I'm not rounding anything off, right? And what does it say? 4.9. Now it says, it doesn't say. Let's say it said rounded off to the nearest tenth. That means that the Buford number would be 4.9. Done. 2 divided by 3. Good question. So again, this is just plugging numbers in and then solving on your calculator, just like you've been doing. Let's try another one. In medicine, the body surface area is used to help determine proper dosage for medications. I use that joke a lot. Whenever anybody asks me if I'm cold, I always say those of us with a low surface area to volume ratio don't get cold. What am I saying about myself? I'm fat. Thank you very much. Yes, I am fat. If you have a low surface area to volume ratio, that means you have a large amount of volume and a small amount of surface area, right? Skinny people have a high surface area to volume ratio, so they expel heat more efficiently and they get cold faster. So this right here, BSA is the body surface area. And it's given by this formula. It's the square root of your weight times your height divided by 60. So this would be another good ACT question. Models of relationship, blah, 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 blah. Solve the equation for H. No, I don't want to do that. I want to do part B. Determine the height. I want to know H. Determine the height of somebody who weighs 90 kilograms. Which letter am I going to put the 90 in for? For what? W. That's the weight. And the BSA is 2.1. So that's obviously the BSA. That's the body surface area. So here's my formula. All I got to do is plug the numbers in. Instead of BSA, what do I write? So write down 2.1 equals the square root of W, which is 90, times H, which I don't know, all divided by 60. Now you have to use your Algebra 2 know-how to solve for H. What shall I do first, McLean? Times 60. Now, when I multiply this side by 60, what happens? It cancels out. So write down the square root of 90H equals, well, I don't know. What is 2.1 times 60? 2.1 times 60, 126. There you go. So write down 126. Now, somebody besides McLean, tell me what I'm going to do next to try to get H all by itself. Okay, you are going to want to divide 90, but remember, yeah, this is kind of like being inside of parentheses. And you always want to do that last. Inside the square root symbol is kind of like being, you got to get rid of the square root symbol first. So how do you get rid of a square root? Square. So square this side and square this side. When you square a square root, what happens to the square root? It disappears and you're left with 90H equals. Well, now it's time to bust out the calculator again. I have no idea. What is 126 squared? It's a big number, 15,876. 15,876. We're almost there. Somebody besides McLean. Thank you. Divide it by 90. Thank you very much, Josh. Divide it by 90. Leave it on there so you don't have to type it in again. Divide it by 90 and you get 176.4. 176.4. That seems awful tall. Or is it?
Divide by 12.
It's in centimeters. Are centimeters different than inches? Does anybody know how many centimeters are in an inch? It's 2.54.
Oh, wait.
So on your calculator, take that number times 2.54, and this, not times 2.54. What do I have to do? Divide by 2.54. Thank you very much. So divide by 2.5. This person is 69.5 inches, which is how tall? 5'9.5". So that's how tall this person is. If they weigh, what was it? How many kilograms? 90 kilograms. They'd be about 5'9.5". Well, you'd put in 164.4 because it asked it, since they gave us H in centimeters, we would answer in centimeters. I just did that because we're Americans and we do things in inches here. So I just wanted to throw the inches in there, see how that works. All right, so you can see that there's all kinds of fun story problems that we could do. Now we're going to save problems 3 and 4 for another time. Turn to the next page, page 78. All right, here's what we're going to do. Instead of doing an IXL, this is your assignment.
Thank you.
It's only 4 problems and you have what, 20 minutes to do it. This shouldn't be that bad. So get all of these 4 answers correct. Ask the person next to you for help if you're not sure what to do. But this is your assignment, these 4 problems. Okay.